Welcome to the Defense and Aerospace Report. I'm Vago Muradian here at the Navy League's annual Sea Aerospace Conference and Trade Show just outside Washington, D.C., the #1 gathering of U.S. Navy leaders from around the world meeting with their international counterparts to talk about security, strategy, technology, and more. Our coverage here is sponsored by GE Marine, Huntington Ingalls Industries, and Leonardo DRS, and we're here at the BAE Systems stand to talk to Sam Bushell, who is a technical program manager in the company's intelligence and security sector. Sam, thanks very much. I know that there's Air Force in your title as well, because you do this stuff that's kind of cross-cutting. Talk to us a little bit. You know, you guys have a model-based systems engineering sort of demonstrator here, but for the audience, you know, we hear model-based design more and more, model-based systems engineering. You know, tell the audience a little bit about how to think about this space, because, you know, it is a very, very novel and innovative way of collaborative sort of developing capabilities.
Well, thanks, Vago, for having me. I guess I would start off by explaining a little bit about model-based systems engineering as not a product, but an approach to understand and develop a technical baseline. The idea is that if we model everything, we can understand everything. We're in the process of implementing this across all of our business units as a way to modernize legacy platforms and help in the acquisition of new systems. We are developing digital twins of all of our products to better understand the life cycle implications of change. That is really where the cost benefit comes from. Our objectives are lower total cost of ownership and reduce risk.
And so talk to us a little bit about how systems like this help. You know, we've looked at virtual reality systems. This is an augmented reality system. Talk to us about some real world applications about how this helps you take cost out of both the development but the long-term sustainment of a complex weapon system, for example, like a ship or something else.
Certainly. So augmented reality allows us to understand digital design elements and bring them into our real world. Unlike virtual reality, where we're shut off from the real world, augmented allows us to interact with real objects at the same time as the digital items. So, for instance, we can enhance our mission capabilities in sustainment and training applications by giving people hands-on actual systems integration approach to these maintenance procedures. We can overlay digital items, TOs, tech manuals, part information, and put that in front of those maintainers so that they have access to all of that information at the click of a button. That is the real cost benefit to that.
Talk to us a little bit about this simulation we've got here. The ship looks slightly Tirpitzian, Bismarckian, but I know that it's part of a whole fleet structure you guys have here. So talk to us about exactly how you're demonstrating it here in your little headset demonstration.
Certainly. So it's not an actual asset. What we're using is a sample asset to demonstrate a proof of concept of how we can use multi-gesture input within the Microsoft HoloLens to understand the manipulation of 3D objects. If we can move it, we can fix it. That's the idea here. So with the augmented reality headset, we can develop against the latest software development kit that allows for multi-gesture input, which gives better real-world applications for those procedures in the field.
And so you can use this whether or not you're trying to trial out a repair procedure, or if you're trying to visualize what it's like to work, for example, in a confined or constricted space aboard a ship, for example, whether for construction or any repair application.
Exactly. It's applicable across the spectrum. By putting people into hazardous situations, you limit their ability to train. So by taking them out and digitizing those same exact scenarios, we can do process repeatability and not expose our warfighters to those hazardous scenarios.
And if anybody who's been on a ship knows, you know, that there are fuel tanks, voids, there are other sorts of spaces in which there are noxious fumes, for example, that'll build up. I mean, even in, you know, bilges and things like that, it becomes something that is grossly unpleasant. But talk to us about how you can model a space, for example, on a ship in order to have folks sort of practice, for example, a complex repair before they go ahead and they do it, because I know you can model that very accurately with this system.
Certainly. So part of model-based systems engineering is bringing the legacy systems into the digital environment, creating the digital twin. Part of that is taking original design drawings, building CAD models, and then developing augmented reality experiencing using those same models. So then you can overlay that into a simple room and fill it as if you were in the engine room.
Do you, you know, there were a couple of companies that are working on this, and I sort of want to get your sense on this, that with, say, Google Glass or some other, I don't want to get proprietary on this, but some form of eyeglass display system, that you can actually help people work through complex repair evolutions so that, what tool sets I need, what repair procedures I need. As you look forward into the future, do you see this sort of fusing with some of these systems to actually, in a real world, somebody puts glasses on and is like, okay, look, here's how I go about breaking down this particular system if they've never done it before, as opposed to saying, okay, well, let's all go down into this void or this cramped space in order to try to do it, right? I mean, walk us, it's almost like limitless what you guys can do with this kind of an application.
Absolutely. I would definitely say limitless. So augmented reality has a lot of hardware platforms. We've decided to go with the Microsoft HoloLens as it's a fully capable multi-gesture voice interactive platform. Now, what this allows us to do is it gives us the freedom to interact with our holograms in ways that other platforms can't. So we can actually manipulate the spatial geometry of our objects in real time, and that allows us to do more accurate training procedures and also inject potential scenarios that you couldn't do without having the ability to manipulate the augmented holograms around you.
Including warfare scenarios, right?
Certainly, certainly.
Sam Bushell of BAE Systems Intelligence and Security Sector. Thanks very much, man. Best of luck with the program. It's absolutely fascinating.
Thank you for your time.